projectile applications in that velocity at any instant. The main application in oblique projectile, what is instantaneous velocity or velocity at any instant of time. Here the body is projected with a velocity here. This is u and this angle it make here is theta. So now at any instant, suppose at this one particular instant I am taking here, at that particular instant the velocity is v. So it has two components every time. Velocity means it will have two components, one in horizontal direction, other one in vertical. In horizontal, let me take the component for v as vx, and here in vertical direction vy. Let me write in vertical direction vy. So the two components I am writing here. So here the body projected first with an initial velocity, body projected with an initial velocity u, making an angle theta with horizontal. Now at some point in its path, the velocity I am taking, that is called as instantaneous velocity, velocity at any instant of time. So here the angle here it made is alpha. Let us take the angle here made it is alpha. So here I am taking the angle as alpha here. So angle is taken as alpha here. So Vx is the component, horizontal component of velocity V, and Vy is vertical component of velocity V. V is instantaneous velocity. Now our target is to find about instantaneous velocity. So you know that resolving into components for initial velocity means I can write ux is equal to u cos theta, and uy is equal to, I can write u sin theta. This is resolving of initial velocity into two components. We know this one very well. Now the starting point is O, and at this instant the point is here is P. So at the P, the instantaneous velocity is V. It is resolved into components as Vx and Vy. I want to find first the values of Vx and Vy. Here V is instantaneous velocity. So as V is here instantaneous velocity here, how to handle? Let us observe carefully here. V bar, vector notation, Vx is along x-axis means I can write positive x-axis I cap plus Vy j cap I can write. This is initial velocity vector, velocity, instantaneous velocity vector. Initial velocity vector is what? Initial velocity vector is u. U is initial velocity. V is instantaneous velocity. So this is instantaneous velocity. Instantaneous velocity. We call it as instantaneous velocity. We can understand this instantaneous velocity by finding the values of Vx and Vy. And first our target is to find the value of Vx, then Vy. If you know these two things, obviously we can find the value of V also. Now let us enter into the topic here. So what I am doing here, my target is to find Vx and Vy. Remember, Vx is horizontal component, Vy is vertical component of velocity at any instant. Velocity at any instant. So let us first target in horizontal direction. In horizontal direction. In horizontal direction means we know that initial horizontal velocity ux is equal to what we can write? U cos theta, already we know. And let us take here. So in the first diagram, from here to here, the time taken to reach from O to P. Let me take the time taken is T. O to P, the time taken is T. The time taken for the particle to travel from O to P is T. So from that information, I am coming back here. It is instantaneous time. So either in horizontal or in vertical, it doesn't matter. Time we call it as T only. Now, okay, what is our target to find? Our target is to find Vx value. First in horizontal direction means Vx. Now the question is, what is acceleration in horizontal direction? My answer is 0. Why acceleration is 0? We discussed in previous topic also. Because When the body is projected in air, any body projected in air will be having vertical acceleration, that is a gravitational force, that is due to gravitational force. In horizontal direction, there is no acceleration. There is no acceleration in horizontal direction because gravitational force will act only in vertical direction. Gravitational force will act only in vertical direction. Now, our target is to find Vx value. For that formula, Vx is equal to, I can write Ux plus Ax into T. Here, Ax value is what we have written is Ax value as 0. This is 0 means Ax into T is also 0. From that information, I can write Vx is simply Ux. Ux is nothing but U cos theta. Even no need to derive like this horizontal direction. In previous topic itself, we told for whenever a body is projected in horizontal direction, body is projected in horizontal direction at every point, here, everywhere on the path from here to here, horizontal direction velocity is constant. Horizontal velocity is always u cos theta. At any instant from starting to ending, any instant, horizontal velocity is u cos theta because acceleration horizontal direction is 0. Velocity is constant. Velocity is constant as acceleration horizontal direction is 0. So everywhere velocity in horizontal is u cos theta. Either this point, either here, anywhere you take, the velocity in horizontal direction is same. Every time what is changing? Vertical velocity is changing. So on, when we are going up, vertical velocity decreases at maximum height, vertical velocity 0. After maximum height, again vertical velocity increasing, and finally reaches to the this ending point, and again it have the same value u sin theta. When it reaches to the ending point, what is the vertical velocity at starting? U sin theta. Here also will be u sin theta. We'll discuss that one later. First of all, horizontal direction velocity is constant because acceleration is 0. Vx value always u cos theta only. Already we derived practically that by showing that in horizontal direction we have taken all these components and we got the answer as Vx equal to u cos theta. Fine. Now our target is vertical direction. Vertical direction. What about vertical direction? In vertical direction means Uy, initial vertical velocity, everyone know u sin theta. Body projected up, a equal to minus g. We know body projected up means a is equal to minus g. T equal to t. So from the diagram easily you can understand what is initial vertical velocity Uy u sin theta. Body is projected up, a minus g, and time taken from here to here is t. So just substituting in vertical direction all those values. What we are getting here, Uy equal to u sin theta, a equal to minus g, and time t equal to t. If you substitute here, so what I am going to get here, beta? Vy is equal to Uy plus At. Here acceleration vertical direction Ay. Time is same. Either you take in horizontal vertical is a simultaneous action. Time is same. So what is Vy value means I can write now. Uy is u sin theta. Uy is u sin theta. A value is minus g into t. Minus g into t. Vy is equal to u sin theta into what we got, Vy u sin theta minus gt. U sin theta minus gt, we got the expression here. So here this is the expression for find that the velocity at any instant in vertical direction. Velocity at any instant in vertical direction. Now we got the two values. Vx value is u cos theta. We derived here Vy value as u sin theta minus gt. These two expressions we got. So starting equation I have written it as, if you remember that V bar is equal to, I have written it as, what is that one? V bar is equal to Vx I cap, Vx I cap, Vx I cap plus Vy j cap. Did you remember this expression now? So V bar is equal to Vx I cap plus Vy j cap. Now Vx value we got u cos theta, Vy value got u sin theta. So from this expression, I can write V bar is equal to U cos theta I cap plus U sin theta minus GT J cap minus GT J cap. So like that, I got the expression here. So this is the velocity, instantaneous velocity formula. What I have written is instantaneous velocity. Instantaneous velocity vector. Instantaneous velocity vector I can write. So simply this is a velocity vector. It is a velocity vector. Now actually I want its magnitude and direction. I want magnitude and direction. Let me take a first page. Here V bar is equal to U cos theta I cap plus U sin theta minus GT J cap. So here V magnitude. Magnitude means you know that you can write it as U cos theta whole square plus U sin theta minus GT whole square, because magnitude is square root of I component square. I component square. This is I component means what is that one? U cos theta. And beside J, what is the component? U sin theta minus J GT. This is beside I the component U cos theta. Beside J the component U sin theta minus GT. So this is the magnitude. V is called magnitude. V is called magnitude of velocity at any instant. Magnitude of velocity at any instant of time, at any instant of time. So instantaneous velocity magnitude. Fine, we are happy with the magnitude. Then they are asking what is direction. Direction, they are asking direction. How to handle direction? Observe here carefully here. We know that what happened, velocity is in this direction V. Vx is in this direction. The angle it makes with Vx is alpha. This is Vy. So here I can also write tan alpha is equal to Vy by Vx. Tan alpha is Vy by Vx. So alpha is equal to, I can write it as tan inverse. Tan inverse Vy by Vx. What is tan inverse? Vy by Vx. Vy by Vx is the formula what we got. Tan alpha is tan inverse Vy by Vx. We know Vx value, Vy value. What are Vx values beta here? U cos theta. What is Vy value beta? U sin theta minus GT. U sin theta minus GT. Now, from this information, substitute that one. Alpha is equal to tan inverse of Vx. Vx means, sorry, first Vy. Vy means U sin theta minus GT. U sin theta minus GT by Vx. U cos theta. U cos theta. Now observe carefully. This is alpha is, I got it as tan inverse U sin theta minus GT by U cos theta. This is called as instantaneous velocity. Instantaneous velocity direction. Instantaneous velocity direction. So we understood now the direction and magnitude of the instantaneous velocity. Let me show all the things at one place here now. Observe carefully. I projected the body like this. This is U. This value I called as U. And this is the value is V. Here what happened, this velocity, we have to draw tangent. So that velocity, if you observe individually, we will observe the V value here. This is V value individually here. This is making some alpha here. Vx is horizontal, Vy is vertical for that V. At any instant, the starting point O and this point is P and time taken is T from reaching O to P. Then what we have written here is V bar is equal to, we derived it as U cos theta I cap plus U sin theta minus GT J cap minus GT J cap. This is the expression what we found. And What is the magnitude we got? V is equal to square root of u cos theta whole square plus u sin theta minus gt whole square minus gt whole square. This is the V is magnitude. And we got third one, direction. Alpha is tan inverse u sin theta minus gt by u cos theta. So I hope you are clear with instantaneous velocity. Instantaneous velocity in oblique projectile. Oblique projectile. This is the information for instantaneous velocity. I hope this topic is clear. About instantaneous velocity, we found velocity at any